Hey everyone, welcome back. Today we are going to talk about mega numbers. So mega here of course mean a million, and this is actually an event in YouTube where everybody shares about their favorite numbers, especially it must be bigger than a million. This event is called #MegaFavNumbers. I think it would be cool for me to share about my favorite numbers if I had one. So I don't have a favorite number bigger than a million. So this video we will talk about the search for my MegaFav number. Let's discuss how can we compute the number of weights. For instance, if we have a neural network with two inputs, so the architecture would look like this. We would have two weights here and one for the bias. Don't forget the bias. So the number of weights will be 2 times 1 plus the number of neurons here, so plus 1. So this would be the number of weights in. If we start with two inputs, if we start with three inputs, then it would look like this. Yeah, this 1 2 1 2 1 2. So the number of weights would be 3 times 2 plus the number of neurons here, because there will be two bias here, two bias. Then we will add the same in the case in the two inputs one, so it would be 2 times 1 plus 1. So how much is this? 6 plus 2, 8, 3, 11. Alright. So that's how we can compute the number of weights. To make it simple, actually, we could actually draw it differently. If we have two inputs here, we will imagine if there is another neuron here just for the bias, then it will be the number of weights. So to make it simple, if there is two input, then the number of weights will be n plus 1 times n minus 1. So it will be 3 times 1. For instance, if this is 3 and 2, so it would be n plus 1 4 times 3 minus 1 and 2. So it would be 8 here. That's the quick tips on how we can compute the number of weights, and that's why I have prepared this code here, and we can see that the formula that we can use here, n plus 1, n minus 1, and for hopefully we can find a prime number of weights. So let's see. Yes, we actually find 3 is a prime, 11 is also a prime, 26 is not, and we have reached 100 layers of neural network. So to make it simple, I have created the code to check if one of these is prime. And actually this is not a mega number, it's still smaller than a million, but let's see if we have 10,000 layers of neural network. So this is just 3 inputs. What if we start with 10,000 of inputs, then goes to 9999, then till 1. Hopefully one of them have a prime number of weights. So let's see. Oh wow, surprisingly we could not find any prime number except this first two, 3 and 11. That's weird. I'm not sure why. Maybe if we can go deeper, more inputs, we could find prime number. So we could try another approach to find the MegaFav number. So here's what we are going to try. Previously we have neural network that looks like this, and we could see that the number of neurons decrease by 1. So the step is 1, step 1, step 1. And we could not find a prime number out of that. That's weird, but I don't know why. So how about if we could use a different kind of steps. Let's say if I start with 3 input, then I use step of 2, so it directly goes into 1 neuron. So the next one would be step of 2, 1, 2, 3, 4, 5. Maybe we could find a prime number of weights. So let's see if we do that. Here I can try starting with step of 1, 2, 3, 4 until step of 10, and the maximum of 10,000 inputs. So let's see. With step of 1, so it would be the same as previous one. We would only find 3 and 11. That would be prime, but still not a mega number. How about if we use step of 2? Turns out that no, we couldn't find any prime number even if we have reached 10,000 of input. How about 3? Interestingly, we find another prime number, 5 and 37. And it looks promising because it's getting bigger. So maybe at one point we can have a prime number that is larger than 1 million. How about 4? 4 also, we couldn't find any prime number. 5 also, again we find one, and this one, this time we can get a even larger number, 2017. 6, 7, 137. It looks promising. 8, 9. Some kind of pattern here. We can see that when we use even number of steps, it would always not result in prime number. It is because when we use even number of steps, it would result with even number of weights. That's why it would not find any prime there. But when we use odd number of steps, it looks promising because the prime number is getting bigger and bigger. So what we can try is make the step larger, I don't know, 500 steps maybe. And I use the step of 2 here to skip the even steps. Alright, so 1, 3, 5, 7, and so on. Hopefully we can find a prime number that larger than 1 million. So let's see. And turns out, yes, finally we find one. So this should be a prime number. We can have a check. Prime check. And yes, it is a prime number, and it's also larger than 1 million. So I would say that this is my new mega favorite number because I didn't have one previously. So what kind of architecture that we find this PrimeNet? So the architecture starts with 727 neuron. So if I draw it, it would be like this. 727 neuron with step of 121. So 121, 606, 122, and finally 1 neuron. So this is the PrimeNet, which finally results in my favorite, my mega fave number of 1,031,053. So that's it. That's my mega fave number, and I hope you like it. Thank you everyone for watching. See you again. Bye.